there's something on 5.1, I can certainly simplify it. Is there something on 5.1 we need to simplify for somebody? Pardon me?
The last one, maybe number 4.
Okay. Can I hold off on that? That's a solve problem. That is not on the quiz, so we can do that, but that's not on the quiz. What is on the quiz? Is there another one? 1, 2, or 3? Which one? 3? Okay. So on the quiz, what number 3 is going to look like? This is from the homework. It's going to look like this. The quiz is going to have an end goal. It's going to have an equals thing over here. You just simplify. But you should have simplified to this. This is the right answer. Now, how do we get from there to there? That's what we need to make sure we know how to do. So when you look at this problem, what I think it's obvious. We're going to try to simplify this and cancel stuff out and end up with this, right? So tell me what occurs to you to do when you look at this problem. Oh gosh, guys, we get no points for doing nothing. So you can sit there and stare at me, but there's no points for that. You've got to do something. Even if it goes nowhere, something will get you some points, right? Bingo. Kids, we got 2 fractions being subtracted. Whenever you see 2 fractions that need subtracted, you should be thinking about getting a common denominator. So, my common denominator will consist of 1 minus sine and cosine. Would you agree with that? That's going to be my common denominator. So now I have to make sure that both of my fractions have that denominator. So this one is going to need to be times by cosine. And this one is going to need to be times by 1 minus sine. Would you agree with that? Now, both fractions have the same denominator now. So I can combine them. So what have I got here? What's the first one going to be? Cosine squared. And then be careful here because this is going to be a distributive. So it's negative sine times 1. And it's negative sine times negative sine. So positive sine squared. Does that make sense? Okay. Now take a good close look at it. You have memorized or will have memorized the first 8 on that colored piece of paper. And this is on there. What's cosine squared plus sine squared? 1. So your numerator is 1 minus sine. 1 minus sine. Your denominator is still 1 minus sine times cosine. Well, I'm screaming at you all the time about not getting away or carried away with your canceling. But when you can cancel the whole shebang, the whole quantity, you're allowed. Even when there's minuses or pluses in it, you're allowed. When you can't cancel is when you have something like this. You can't say, oh, I'll cancel off the signs. No, you can't. You can only cancel when you can do the whole thing. Okay? Well, when I do that, what am I left with? 1 over cosine. And what's 1 over cosine? Secant. Okay? All right. Is there another one from that homework or from the 5.2 homework? Has anybody started the 5.2 yet? That's due soon.
Can we do number 3?
On the 5.2?
Oh, yeah.
Yep. So that is, this homework, 5.2, this is what your quiz is going to look like. I haven't written it yet, so I'm not sure if there'll be one or two problems. At least one, no more than two problems. And you will have to change one side into the other side. Okay. So look at it, and remember, you can't just sit there and stare. You've got to jump in. As cold as the water might be, you got to jump in. So May, what's your thought?
Do we want to change tangent to sine and
Absolutely, you could. Now, let's look at this one. Isn't 1 over tangent cotangent? So this one would actually change into cosine over sine. Now, is that too confusing? Did everybody follow that logic? 1 over tangent is cotangent, right?
Yeah.
And so, since this is really cotangent, that's cosine over sine. And then this one is sine over cosine. They always show me this. Okay? All right. Now, look at what you've got here, kids. We just had this. We just talked about it. What am I going to do now? I'm going to add those. I need a common denominator. So my common denominator will be sine cosine. So this one needs a cosine. And this one needs a sine. You have to make your denominators look alike. So you're going to multiply them by what each one individually by whatever it needs to match the other one. All right, so what do I got now in my numerator? Cosine squared. Oh my gosh. And cosine squared plus sine squared is 1. So we have 1 over sine cosine. Now, this is where you have to kind of just think for a second. We don't normally do this, but would that right there be the same as 1 over sine times 1 over cosine? Is this, if you multiply these together, is that what you would get? Yeah. So we don't normally pull them apart like that, but this time we have to, because what's 1 over sine? Cosecant. And what's 1 over cosine? Secant. There we go. We've got it. We've got it. Okay, so let's do one more. I can either throw one at you, or if you see another one there on the homework that looks interesting, or if you tried it already, we can do it. Does anybody?
Maybe number 2.
Uh-huh. Yep, we sure can. Now, number 2 doesn't have anything to do, at least in the beginning, with getting a common denominator, does it? No, number 2 is one big giant fraction. Well, it's not so giant, but it's secant squared minus 1 over sine. And I want that to equal sine over 1 minus sine squared. All right, so I want you to think about what you've memorized. Think about what we've got over there, because I think we'll start over here. This kind of looks a little confusing with secants and sines. Does secant squared minus 1 pop out at you? Hopefully it does. Not that you necessarily have that memorized, but don't you have this memorized? 1 plus tangent squared is secant squared?
Mm-hmm.
So if you take that equation and move the 1 over here, then you would have secant squared minus 1. And what does secant squared minus 1 equal? Tangent squared. So I'm going to go ahead and think of that as tangent squared over sine. Now you might be thinking, Mrs. Ford, that's not what I wanted, and you're right, but I'm not done yet. tell me about tangent squared. Sine over cosine. So maybe I would think of this as sine squared over cosine squared over sine over 1. Now, I got this fraction divided by another fraction. Well, what do I do when that happens? Multiply by the reciprocal of the one being divided by, down here. So now I'm going to have sine squared over cosine squared times 1 over sine. What happens now? We can cancel. So sine goes in here. So now I have sine over cosine squared. Well, keep an eye on what you're going to end up with. There's no cosine in my answer here, the thing I'm trying to get. There's no cosine in there. So do I know anything about cosine squared? It's 1 minus sine squared. And again, we use that one a lot, so you might memorize it, but what you really have to memorize is sine squared plus cosine squared equals 1. Then you can rearrange this lots of different ways, but one way is to bring the sine squared over here, and then it says cosine squared equals 1 minus sine squared. So that is 1 minus sine squared. So I'm out of room, I got so much stuff, but it's sine over 1 minus sine squared, and that's what you wanted to end up with. Okay? All right. So your quiz tomorrow, I gotta get through our notes, and if we get where we need to go, then I'll do some more practice with you, okay? But that's a start, anyhow. That's a start. Okay, or maybe I'll do one more. This is the last period of the day, right? I'll do one more. Let me pick one. I'm gonna pick one off our extra practice sheet here. By the way, I picked several during B period, and that will be posted. So if you want some extra practice, I did some with them. I'm gonna pick different ones to do with you, so between your class and the video of the other class, you will have some practice problems if you wanna practice some more. Okay, so I'll pick another one from this sheet that I gave you a while back. Let's see. I don't think I've done this one, but let me do it. So I got cotangent squared over cosecant plus 1 minus cosecant equals 0. Okay? Well, does everybody see how this all equals 0? So wouldn't that imply that all this has to cancel out? And to make it all cancel out, wouldn't it be easier if it was all the same variable? So I've got a cosecant and a cosecant and a cotangent squared. Lily's hand is up. What, Lily?
The cotangent changes to cosecant minus 1.
Exactly. You have memorized that 1 plus cotangent squared equals cosecant squared. By the way, you're dead in the water if you don't memorize these, so please memorize them. You've memorized that 1 plus cotangent squared is cosecant squared. So, if I move the 1 over to here, then cotangent squared is the same as cosecant squared minus 1. So I will do what Lily said, and I will substitute in cosecant squared minus 1. cosecant squared minus 1 should kind of jump out at you, not because of any identity, but because it's factorable. Why is it factorable? Difference of squares. So it will factor into cosecant plus 1 and cosecant minus 1. Now, factoring is on my mind because I gotta get rid of a whole bunch of stuff here. And won't canceling potentially help me? But before I can cancel, I have to factor. So I factored. Can I cancel? Why, yes, I can. So what am I left with after I do that? Yep, because I've got cosecant minus 1 plus 1 minus cosecant. Doesn't it all cancel out? And leave me with 0.
Miss Ford,
Yes.
Kirsten, she's in the waiting room.
Oh shoot, I didn't notice that. Thank you very much. She was here. She must have gotten kicked out or something. Sorry, Kirsten, I didn't notice you'd left.
That's okay, thank
I
you.
was too excited by all this. All right, so I'm going to do one more. And here's the thing, and I know I've said this to you already, but when I hand you this sheet of paper tomorrow, go with whatever you can think of, right? And it may take you where you want to go, and it may not, but at least you'll get something out of it, right? Don't sit there and worry about, oh, should I do that? Just do it. Things to do. Common denominators. Changing, well, I just erased it, but changing cotangent squared into cosecant squared minus 1 or whatever it is, right? Those are the things that can get the ball rolling. All right, we'll do one more, and then I really do have to get to the notes. So last one for now. If we have time at the end, we'll do some more. 1 over tangent plus cotangent, and it's 1 over all that, equals sine times cosine. Okay, what's your thought? Pretend this is tomorrow. Here's the question. What are you going to do? What's something that's going to give you points?
I would switch the tangent to sine over cosine and then cotangent to cosine over sine.
I think that sounds absolutely magnificent. I'm sitting here thinking, what else can I do? I mean, that seems like a good way to start. This is called a complex fraction, and it actually happened to us in several problems we did this morning. So if what I'm about to do confuses you, make sure you go back and watch that video when I get it posted, because we did 3 or 4 problems where we had a situation like that this morning, okay? You can do one of 2 things. It's whatever flips your switch. You can go ahead and get a common denominator down here, add those together, and then invert and multiply. That will work. It's 2 steps. I'd rather do it in 1. You can always clean up a complex fraction by looking at each piece of the fraction. So a complex fraction is a big fraction with little fractions inside of it, which is what we have here. Look at the little fractions, and I circled them. There's 3 of them. Look at the little fractions. What is the common denominator of all of the little fractions? Sine, cosine. So simply multiply each piece, each little fraction, by the common denominator. So we're not getting a common denominator, we're not inverting and multiplying, we're simply multiplying everything by the common denominator of the individual fractions. Now, It didn't do me any good on the top. The top is just gonna be now sine, cosine. But look what it does on the bottom. On the bottom, it cancels out these things so they're not fractions anymore. So the cosines will cancel, and that term is just gonna be sine squared. And then the sines will cancel, and that term is going to be cosine squared. Whoa, 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 wait a minute. What's that? So guess what? We got it. It's sine cosine. All right, I promise that we'll do some more once I get through just a few notes. I don't have a lot to do, but we've got to make some progress.